The unveiling of an ultra-high performance sports car claimed 0160 kph in 3.8 seconds at a major low-carbon vehicles event might seem unlikely, but that is where project partners Ariel Motor Company, Delta Motorsport, and Equipmake chose to launch their hipercar prototype. The name translates as High Performance Carbon Reduction, a project that has the blessing of the UK government via Innovate UK, the country's innovation agency, which has contributed a £2 million grant. Hipercar, with mini turbine range extender, will be built by Ariel, manufacturer of high-performance niche models including the Atom. It aims to use the vehicle as a high-profile launchpad for technology applicable to other niche, medium and ultimately high-volume production. Ariel's director, Simon Saunders, told Automotive Engineering one of the most interesting things about hipercar is that you can now go faster, greener. New technologies will not only allow our and future cars to be more environmentally friendly, meet UK and global emissions targets, but will also outperform a conventional ICE car. It's good news for air quality, it's good news for the economy, but above all it's good news for our customers at the UK's Cenexlf Expo 2017 at Millbrook Proving Ground. Saunders revealed the car's rolling chassis with its main components installed, with the aim of showing the advanced technology. Unveiling of the complete bodywork will come later, the opposite of most new vehicle reveals which usually put styling above technology. Torque Monster. The platform unveiling came at the completion of the initial R&D phase of the car's development. Now, supported by a further £6 million grant from the Advanced Propulsion Centre, the three partners will be joined by GK and Hybrid Drive, Johnson Matthey, and Semicron for further testing, development, and, ultimately, production in 2020. Hipercar has an inboard motor for each driven wheel. There will be odd and 2WD versions with integrated gearbox and inverter. Each motor will deliver 220 kilowatts, 295 horsepower and 450 Nm 332 lb-ft. So in odd form, power output will be 880 kilowatts, 1180 horsepower. Claimed peak torque is 1800 Nm 1327 lb-ft at the motor and 9900 Nm 7302 lb-ft at the wheels. Motor, gearbox and inverter assembly weigh a total of 57 kilograms 126 pounds. It has a microturbine gasoline-fueled range extender producing 35 kilowatts 47 horsepower. The odd battery pack uses liquid-cooled lithium-ion cells with 42 kWh capacity and the 2WD of 56 kWh pack. The APM 200 motor selected for hipercar has been developed by Equipmake working with software specialist Motor Design Limited. It has novel rotor architecture and an aluminum housing having a diameter of 318 mm 12.5 in and weighing 40 kilograms 88 pounds. Magnets are positioned like the spokes of a wheel around the outside of the rotor instead of in a more conventional V shape on the outside of the rotor laminations. The result is described by Equipmake as producing an increase in torque density of some 25% compared to a conventional rotor. Direct cooling of the magnets is via water glycol. The single-speed gearbox with reduction ratio of 5.51 is epicyclic and weighs 9 kilograms 20 pounds. Its cooling system is shared with the motor. Inverters are positioned above and connected to the motor. Delta Motorsport has developed two battery systems, odd and 2WD versions for the car. The odd has a peak voltage of 750 volts. Maximum power capability is cited as over 1500 kilowatts 2011 horsepower. Microturbine with recuperator. The microturbine is also a Delta Motorsport development, having a 35 kilowatts 47 horsepower output, running at a fixed 120,000 RPM that generates power to maintain battery state of charge. Battery management automatically selects the turbine as required, but there is also a manual override. A gas turbine solution was chosen partly for its light weight of less than 50 kilograms 110 pounds. A recuperator reduces emissions, particularly NOx, stated Delta Motorsport engineers. Computational fluid dynamics CFD techniques used for F1 race cars have been used by specialist Total Sim to meet required drag, downforcing cooling systems requirements. The car has a folded and bonded aluminum chassis and removable front and rear subframes with billet machined and anodized aluminum interfaces. Unequal length aluminum double wishbones are used. Carbon composite wheels, an option for production cars, are fitted with Michelin Pilot Cup Sport 2 tires. The car's electrical architecture uses high and low voltage systems linked by multiple CAN networks. Each seat weighs 9 kilograms and is made of carbon fiber tube. They recline and are pressure mapped. A version of those shown on the prototype will be used in production vehicles. The hipercar will receive a model name later in the development program. It will need to be particularly descriptive. This is the first true electric supercar that will cross continents, drive to town and lap a racetrack, said Saunders.